Okay. I think last class we have discussed about the periodic function and some examples we have taken. Please remember that definition of the periodic functions and all those things. Now, today we'll take one more new type of function, which is a unit step function, or which is also called a Heaviside function. Okay. First, we'll discuss about the definition of the unit step function. Then we'll move forward. I think sir has covered this. Still, I want to revise this. Okay. See, unit step function means the unit step function is denoted by u of t minus a, or it is also unit step function is also called as a Heaviside function. If it is a, it can also be represented as a h of t minus a. Both are one and the same. Okay, so nothing to worry about this. If it is given as h of t minus a or u of t minus a, no difference in that. Okay, now this Heaviside function or unit step function, it is defined as u of t minus a or h of t minus a, that is equal to, it takes the value 0 whenever t is less than or equal to a, and it takes the value 1 whenever t is strictly greater than a, where a is a positive constant. What does it mean? What does it mean? See, I will tell you. If we take a, if we plot a graph of this, the rectangular coordinate system, okay, let us take this as a t, okay, and this u of this is t minus a. Usually we'll write it as u of t minus a. Sometimes to twist the question, they will give it as a h of t minus a. That is also same. Now we'll mark this is origin here 0. We'll mark some point somewhere here. Okay, because we are saying a is positive, so we should mark on the positive this one. Okay, this is a. This unit step function means what happens in this part. In this part, your function, your see this t is less than a, means in this part t takes the value 0. Okay, and after that up to infinity, this is t greater than, t strictly greater than a, means from this t will be greater than a, because we have marked this point here. Now up to this point, that will be 0, and after this point it moves it is a unit. Okay, it moves like this. Okay, so this is called, that's why it is called a unit step function, because here in this part, if you go here, it is 0, suddenly it jumps to 1, and from this it is a constant up to, you can consider up to infinity. So it is a step like function, so it is called a unit step function, because it is jumping only 1 unit, so it is called a unit step function. Is that clear? Okay, next now the Laplace transform of a Heaviside function or unit step function, it is given by L of u of t minus a or L of h of t minus a. It is given as e to the power minus as divided by s. E to the power minus as divided by s. Now let us see how you will got this. Okay, now by the definition of Laplace transforms, now this is here, consider this as your f of t. Consider this as your f of t. What is the definition of Laplace transform? Laplace transform definition is L of f of t. If it is there, basic definition, I told you, you should remember that. That is L of f of t. This is equal to, this is integration 0 to infinity e to the power, sorry, 1 minute, e to the power minus st. This is here, don't get confused. E to the power minus st into this is f of t dt. Okay, f of t dt. Just 1 minute. Okay, f of t dt. 1 minute. This is e raised to, e raised to. Okay, now using this basic definition here, this is your f of t. So what we can write, integration 0 to infinity e to the power minus st into this is your f of t, that is u of t minus a with respect to t. Now this function u of t minus a, that is unit step function, is defined, is a discontinuous function. It is defined in the two intervals, whenever t is less than or equal to a, or whenever t is strictly greater than a. Two intervals. This entire is divided into two parts. So we can write this one as integration 0 to a e to the power minus st into u of t minus a dt plus a to infinity e to the power minus st u of t minus a dt. Now in this part, whenever t is less than or equal to a, what happens? This function is 0, so we have written 0 here. So this integral becomes a 0. Now only we need to evaluate this, that is integration a to infinity e to the power minus st in this part, that is here in this part. Okay, in this part continuously. Okay, what happens? It takes the value 1, so we have written here dt. Now so we have to only integrate this. What is the integration of e to the power minus st? E to the power minus st divided by minus s. The limits are from a to infinity. Now this is, I'm sorry, this is t is equal to a to infinity. So what happens? Minus 1 by s is constant. We'll take that outside. Now we'll put wherever t is there, we'll put upper limit minus lower limit. That is, we can write it as a minus of 1 by s into e to the power minus infinity minus e to the power minus as. Okay. Now what is e to the power minus infinity value? What is the value of this? Yes. Anybody? E to the power minus infinity value is 0, then becomes minus e raised to minus as. So if you multiply this into this, what you will get? Minus into minus plus e raised to minus as divided by s. Therefore, what is your conclusion? Laplace transform of unit step function or Heaviside function u of t minus a or h of t minus a is e to the power minus as divided by s. For example, if you take a here, if they ask you to find a Laplace transform of u of t minus say some 2 here. So how we are going to write this? You should remember this property. You should remember this basic result. You can write this one as a Laplace transform of this is e to the power minus 2s divided by s, because in place of a you have 2 here. Suppose if you have Laplace transform of u of t plus 3, how you are going to find this? Yes, whatever it is there that you have tried, you can write this one as using the basic definition. Laplace transform of a is equal to plus 3 is there, 3s divided by s. Is that clear? Is that clear? Am I audible clearly? Am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Okay. Now you should remember at least this result. So these are for understanding purpose we have taken this. So directly, if it is given u of, or sometimes they will instead of this u they will write this one as h of t minus 2. The result will be same. H and u are one and the same here. H means it is a Heaviside. U means unit. Both meaning both represent the same meaning. Is that clear? Okay. Now one of the property we'll take here, which is very important property. See, if you understand this and this property, remaining things will become very easy. See, Laplace transform of f of t minus a into u of t minus a means this u of t minus a is multiplied by some function which is represented usually by f of t minus a is equal to see, instead of that also u of t minus a, they can take this as h of t minus a. This can be written as e to the power minus as into L of f of t, or sometimes directly we will write this here. This can be written as in some books e to the power minus as into what is your L of f of t? Yes, what is your L of f of t? This is, yes, f bar. Yes, this is f bar. Yes, we can write this as a f bar. Yes, no issues. Now for quickly we will understand, or we will derive this result for understanding purpose, and then we will move to the some examples immediately after this. Will it be okay? Will it be okay? Will it be okay?
Yes, sir.
Okay.
Yes, sir.
Okay. Now consider Laplace transform of f of t minus a into u of t minus a. Now again, by using the basic definition, this entire thing is treated as a your f of t. So what we will do there? Integration using basic definition, integration 0 to infinity e to the power minus st into f of t minus a into u of t minus a with respect integration with respect to t, that is dt. Now, this function u of t minus a, this is defined into two intervals. So it split the interval, that is integration 0 to a e to the power minus st f of t minus a as it is u of t minus a done, plus integration a to infinity e to the power minus st the f of t minus a u of t minus a dt. Now, in this part of the interval, what happens? This unit step function takes the value 0. So this entire thing becomes a 0. See here, let us check. See, integration 0 to infinity e to the power minus st. This f of t minus a, let us keep this as it is. Then this u of t minus a takes the value 0. Then this is a integral plus integration a to infinity e to the minus st f of t minus a as it is, and in this interval u of t minus a, whenever t is greater than strictly greater than a, it takes the value 1 we have written here. Now what happens? This is multiplied by 0 means this is multiplied by 0 means what happens? This completely this integral goes to 0. Now we have to evaluate only this integral. Now, how to evaluate this integral? See, directly it is not possible. So what we need to do here is just we need to substitute this t minus a is equal to something. We'll change this variable. Okay, it is let t minus a is equal to, let us put that is equal to v. If you put t minus a is equal to v, and then what you have to do? You have to differentiate this with respect to v. So what happens? This is a dt is equal to, you will get dv, because here if you differentiate this with respect to v, this is a dt by dv minus 0 is equal to 1, you will get dv by dv. So if you cross multiply, dt is equal to dv, you will get. Whenever you are changing you are substituting for something, what you have to do? You have to concentrate on these limits also. These limits are usually here for t is equal to a to infinity. So what happens here? To get the limits, you have to put those limiting values here. See, when t is equal to a, if you put here, what happens? This becomes a minus a, that is v is equal to 0, you will get. So whenever t is equal to a, v value will be 0. Okay, then next, put a upper limit infinity. When t is equal to, if you put infinity, infinity minus a is also infinity. Therefore what happens? Whenever t is infinity, v becomes infinity, substituting all these in this part. So what happens? What you will get? v2 integration v is equal to 0 to infinity e to the power minus st is there. See, t is sorry, t minus a is v means you have t becomes what? You have to express t in terms of v. So t is equal to, you will get v plus a from the substitution. So I will substitute the t value here, e to the power minus s into v plus a. Then this becomes f of v, f of v dt is dv. Now what we will do? We will apply theory of indices, and or we will take this s inside. Applying theory of indices, you can write integration 0 to infinity e to the power minus sv plus into minus is minus e to the power minus as f of v dv. Now what happens? This e raised to minus as, a is also treated as constant. You are integrating with respect to v. S is also treated as constant. So this term should be taken outside. Now you left with what? Integration v is equal to 0 to infinity e to the power minus sv f of v dv. Now I will write this part as L of f of t. Am I right? Am I right? Actually, this becomes L of f of v. Then we can put by setting v is equal to t. By setting v is equal to t, what happens? It becomes integration t is equal to 0 to infinity by setting v is equal to t e to the power minus st f of t dt. It becomes which is original definition of the basic definition of the Laplace transform. So by the basic definition of the Laplace transforms, we can write this as a L of f of t, or it is a L of f of t is written as a f bar s in short. So it is e to the power minus as f bar s. Okay, means therefore what you should do here, at least you should, if you don't remember the proof, it's okay, but at least you should remember, you must remember which all the things you must remember, at least Laplace transform of u of t minus a or h of t minus is e to the power minus a s divided by s, and this result, this property, Laplace transform of f of t minus a to u of t minus a, or Laplace transform of f of t minus a into h of t minus a is e to the power minus as into Laplace transform of f of t. Now this f of t is now next see, now what is the thing there? You have to note this. It is possible to express a discontinuous function f of t in terms of unit step function, and in turn we can find its Laplace transform using both the properties, basic definition and one of the property. Means whatever the functions, they will give discontinuous functions, those can be expressed in terms of unit step function. Okay, how to express them we'll discuss here. Suppose if your function, if your discontinuous function is a your function is discontinuous at only one point, say at t is equal to a, okay, then that can be, your function can be given as a, if f of t is equal to f1t whenever t is less than or equal to a, f2t whenever t is greater than a, this is discontinuous function, then this f of t, this can be expressed in terms of a unit step function as a f of t is equal to f1t, first function you have to keep as it is, this is first function, okay, then plus f2t minus f1t, f2t minus f1t into u of whatever the this value is there, that u of t minus a, you have to write. This is expression of your discontinuous function, which is discontinuous at only one point, that can be expressed as a what we can say unit step function like this. Okay, then next we'll consider one more thing here. Whenever your function is split into three parts, that is, if f of t is f1t whenever t is less than or equal to a, and f2t whenever t lies between a to b and some, see, if you take this is, if you fix one point a here, fix one point a here, fix one point b here, fix one point b here, okay, this is in this part if it takes the f1t, in this part it will be f2, and above this it will be f3, okay, above this it will be f3. Then what happens, this is t, this is t, this is usually u of t minus, sorry, u of this is t minus a, okay, is that clear? Clear or not? Am I going a bit fast? Will it be okay? Will it be okay? Is it okay?
Yes, sir.
Okay. Now see, see, this is your f of t, discontinuous at 1.2 point. Then what happens? Then what we can say that L of f of t, this can be expressed in terms of unit step function as f of t is equal to, see, first function as it is, plus second function minus first function, into u of t minus a, u of t minus this a, that this you can take, then plus f3t minus f2t, f3t minus f2t into u of t minus whatever the upper bound is there. Is that clear? Is that clear?
Yes, sir.
Okay, these two are very important. So this helps you to express a unit step function, sorry, express discontinuous function in terms of unit step function. Then and hence you can find the Laplace transform of them. Okay, see this expression, and if it is splitted into three parts, this expression are very important. Okay, now what we will do, we should remember what all the things here. We should remember this result, we should remember this result, and we have to remember this, how to express discontinuous function into unit step function, and we have to remember this. Now depending on these these four quantities, we are going to take some examples. Okay, now before going to take the examples, let me brief you how to first how to convert given examples and how to apply these properties and how to solve the examples. Suppose, see, suppose if you are given with if you are asked to find a Laplace transform of some f of t into u of t minus a. Here, this f of t should be considered as a f of t minus a. Okay, then this f of t minus a, to what you have to do is, see there one quantity is there, you have to find by the property, you have to find f bar s. Okay, to find f bar s directly, if you apply Laplace to this, it is not possible. It is f of t minus a. Now what you have to do, you have to convert this f of t minus a in terms of f of t, in terms of f of t. Then you have to apply Laplace to this, then you have to apply Laplace to this, that gives you the f bar s. So for that purpose, what you have to do, let me explain this. For that purpose, what we have to do, how to convert this f of t minus a into f of t? Very simple thing. See, I want t only here, I don't want a. So change t to t plus a. Wherever t is there, replace, see in the next stage item, replace wherever t is there it by t plus a. That gives you f of t plus a is equal to, that gives you f of t, or that gives you the f of t. Then after that, apply Laplace to this f of t, you will get a Laplace transform of f of t. Okay, then therefore what you can write, Laplace transform of f of t u of t minus a, that is Laplace transform of f of t minus a into u of t minus a. That can be written as where, see, don't get confused, where this f of t is nothing but in this form, f of t minus a. So if it is in this like this, what you have to do first, don't worry about anything, we have to convert this f of t minus a, okay, in terms of f of t by changing, making some manipulations. Then afterwards, you have to find Laplace transform of that, and into concentrate on this a, e to the power whatever it is there, by using basic definition, what you have to, Laplace transform of u of t minus a is e to the power minus as divided by s is there, that is not valid because we have already proved this. Okay, so what happens, e to the power minus a is into Laplace transform of f of t, you have to write. This is the working rule or technique to solve the problem. Is that clear? Is that clear?
Yes, sir.
Am I going fast, or will it be okay? Will it be okay? Okay, we'll take some examples here. Okay, see, find the, your examples will be like this. Find the Laplace transform of e to the power t minus 1 plus sine of t minus 1. If they give only this much, then also you should take this one as unit step function. Then definitely they are going to give this, that is find if it is in terms of unit step function, u of find the Laplace transform of e to the power t minus 1 plus sine t minus 1 into u of t minus 1, or sometimes they may give this one as a yes h of, they may give this one as h of t minus 1. Both are one and the same. Okay, now see here, which property you are going to use here? Can anybody see? I will tell you. This is, see, this is one function, it is multiplied by u of t minus a. Now therefore this entire thing, this becomes your f of t minus a, f of t minus a. So what we will do here, they are asking you to find the Laplace transform of this, so we will apply Laplace to this. One step by step we will go. Laplace transform of e to the power t minus 1 plus sine t minus 1 into u of t minus 1. Now see here, you are according to this property, what happens? Yes, u of t minus 1, wherever see it is a t minus a type, so wherever a is there, a value is given as 1 here. Okay, so what happens? You can write e to the power minus s as it is into, this is given as f bar s. Now what we have to do? What we have to do? You have to write first this step. Okay, then our intention is, one thing is over, now we have found this. Now our intention is to find only this f bar s. If you find that, then what happens? F bar s means you have to find a Laplace transform of f of t, Laplace transform of f of t. Is that clear? Okay, now to find that, what we need to do? This is of the form what I told. This is of the form f of t minus a. Therefore, here a is equal to 1 is there. So we can write here f of t minus 1 in this particular example. That will be equal to e to the power t minus 1, e to the power t minus 1 plus sine t minus 1. Is that clear? Is that clear?
Yes, sir.
ಹೇಳ್ರಿ ಏನ್ ತಿಳಿತೋ ಇಲ್ಲ. Okay, then next, so what we have to do there? We don't want this, we cannot find Laplace transform of this. Now we have to find a Laplace transform of f of t. So I want f of t here. So what I will do here? Changing this t to t plus 1. Okay, t plus 1 to get f of t. In the LHS as well as in the RHS, wherever t is there, you have to put t plus 1. So that gives you f of t plus 1 minus 1, then equal to e to the power this t is t plus 1 minus 1 sine t plus 1 minus 1. Is that clear? So here this one get cancels, here this one get cancels, here this one get cancels. You will get f of t is equal to e to the power t plus sine t. Okay, plus sine t. Is that clear? Now, therefore, what you have to do? This is your f of t. F of t of what? This quantity. Okay. Then applying Laplace to both the sides. If you apply Laplace to both the sides, what you will get? Laplace transform of f of t is equal to Laplace transform of e raised to t plus sine t. Now, you already know Laplace operator is a linear operator. So, what we will do? Apply this separately to this. That is, Laplace transform of t is what? Laplace transform of e raised to at is what? Plus at. 1 divided by s minus a. Here a is equal to 1 is there. Therefore, Laplace transform of e to the power t is 1 divided by s minus 1. 1 divided by s minus 1. Then applying this to Laplace to sine t. Laplace transform of sine at is a divided by s square plus a square. But here a is equal to 1 is there. So what happens? Laplace transform of sine t is 1 divided by s square plus 1, which is f bar s. Laplace transform of L of f of t is denoted by f bar s or not? So this f bar s value you have to pick up and you have to come back to this result. So you have to put that value here. You have to put that value here. Is that clear? So what we will do? Therefore, Laplace transform of e to the power t minus 1 plus sine t minus 1 into u of t minus 1 is equal to e to the power minus s into 1 divided by s minus 1 plus 1 divided by s square plus 1. This is the answer for that. Is that clear? Hope this example is clear. Okay. Quickly, we'll take one more example. Find the Laplace transform of sine t into u of t minus 5. Okay. This is your given function. U, or sometimes they will give this one as h. Keep in mind, h of t minus 5, both are one and the same. Okay. Now, we'll apply Laplace to this. Consider this part. It is a Laplace transform of sine t into u of t minus 5. See, this is of the form, here a is equal to pi is there. Therefore, this is of the form what? F of, I'm sorry, just 1 minute. Yes, this is of the form f of t minus pi. A value ಅಂತ ಅದನ್ನ t ನೊಳಗೆ ಇದನ್ನ ಮಾಡಬೇಕು. Okay, then t minus pi ಅಂತ ಇರ್ತದೆ, this part. So this is u of t minus pi. So what happens according to the property? Which property? According to this property or second property, what you have to do? This is your f of, don't worry about this, just you have to write, this is your f of t minus pi here, a is equal to pi there, though, therefore what you are going to write, e to the power minus pi s into f bar s. Now this is what we have to find, only this much, and you have to substitute here. Finding this is very very important, huh? So next, here what happens, f of t minus pi is equal to, they have given this as a sine t, but we don't want a f of t minus pi here, we cannot find Laplace transform of f of t minus pi directly, so I want f of t here. So what we will do, changing t to t plus pi. Okay, so what happens, we get say f of t plus pi minus pi is equal to sine, wherever t is there, you have to put t plus pi, sine t plus pi. So what happens here, this pi get cancelled, this part becomes f of t. Now this is sine t plus pi, I will write this one as minus sine t, because of the standard result, sine pi plus theta or theta plus pi is minus sine theta. Okay, therefore applying Laplace to this, Laplace transform of f of t, which is equal to Laplace transform of minus sine t minus, I'll take outside, I'll apply Laplace to this sine t, that becomes minus 1 divided by s square plus 1. So that becomes what here, f bar s. So this is your f bar s. Now pick up this s bar s, f bar s, and substitute here. So finally you will get a Laplace transform of sine t into u of t minus pi is e to the power minus pi s into bracket minus 1 divided by s square plus 1, you can write, or minus e to the power minus pi s divided by s square plus 1, you can write. This is the final answer for this. Is that clear? Is that clear?
Yes, sir.
Hope I am audible clearly. Hope I am audible clearly.
Yes, sir.
All are there, or only some persons are there? All are there? Yes.
Yes, sir. Yes, sir.
Uh, Next, we will go to the one more important example which has been asked in your examination sometimes. See, find the Laplace transform of find the Laplace transform of 3 into t square plus 4t plus 5 into bracket u of t minus 3. See, u of t minus 3, h of t minus 3, the terms like this comes, you should think that this is a unit step function. So we have to remember those unit step function properties and basic results. Okay. Now, apply Laplace to this first thing. So, Laplace transform of 3 into this u of t minus 3. So, here this is what? This is f of t minus 3 equal to, okay? Usually you have to remember this. Okay, then what happens? This is your f of t minus 3 into u of t minus 3. So if you apply Laplace to that, a is equal to 3 here. So you can write this is equal to e to the power minus 3s into f bar s. What is this f bar s? Yes, we have to convert this. This is f of t minus 3 is there. We have to convert this f of t minus 3 in terms of f of t. Then we have to apply Laplace, that gives you the f bar. Yes. So let us check here. Here f of t minus 3 is equal to what you are having? 3 into t square plus 4t plus 5. Now changing wherever t is there in both LHS and RHS, wherever t is there, changing that to t plus 3, that is f of t plus 3 minus 3 here. Okay, so here 3 as it is into bracket, wherever t is there, you have to put t minus, I'm sorry, this is t plus 3, I think, or t plus 3, we have to put, so I have gone a little bit wrong here, I will make that correction. Okay, t plus 3 you have to write. So it becomes f of t plus 3, then this is the t plus 3. Okay, t plus 3 whole square plus, this is because of typing mistake, don't worry, I will make the correction. Then plus 4 times, this is t plus 3, then this is 5. So this becomes 3 as it is. Expand this using, see here, this cancels, I'm sorry, this becomes f of t. 3 times, simplify this, t square plus this becomes plus 60, this is plus a plus b whole square formula, a square plus b square plus 2ab. So this becomes t square, okay, a square, then this is b square, then this is 2ab, 3 into 2 into t, that 3ab, then this is 4t plus 12 plus 5. Am I right? So f of t is equal to, just strike out this because we have gone a little bit wrong there, okay. So what happens? So this becomes 3 into bracket, we will make the correction here only, 3 into bracket t square, no other term is there, so we'll write that as a t square, then this is 60 plus 40, 60 plus 40, how much it becomes? Yes, can anybody? 10t, am I right? Then this becomes yes 7. Am I right or wrong?
Yes, sir.
Okay, because of this typing mistake I did there, some mistake there, we'll make that correction, okay. 12 plus 12 plus 5 is 12 plus 5 is 17, 17 plus this 9 is how much it is? 17 plus 9 is how much you will get? Yes,
26.
26, okay. Therefore this is a Laplace, apply Laplace, take this 3 to 3 inside this, so it becomes a, just please don't worry about this, this is completely, we have gone wrong here, okay. Then applying Laplace to this, so this becomes a f bar as Laplace transform of this quantity, that is equal to 3 into this is yes, Laplace transform of Laplace transform of t square is what? This is t square is what? Laplace transform of t square. You have to use Laplace transform of t raised to n. What is that? This becomes I told you, you have to remember this, n factorial divided by s raised to n plus 1. So that becomes 2 factorial divided by this becomes n is equal to here, so s cube plus this is 10 into Laplace transform of t means t is n is equal to 1 here, it becomes 1 divided by s square plus Laplace transform of 26 means 26 is constant, you can take that as a outside and it becomes 1 divided by s. Now this 2 factorial is also 2, so you will get I will make the corrections here. So this is equal to e to the power minus 3s as it is, so this becomes 6 divided by s cube, then this becomes plus plus this is 10 divided by 10 divided by s square, then this is plus 26 divided by s. This will be the final answer. Please make this correction, because of some typing mistake I have gone wrong there, okay. Will it be okay? Will it be okay? Have you understood this? Have you understood this?
Yes, sir.
Tell me whether you understood this step or not. All of you?
Sir, what about into 3?
We have taken this 3 inside, no? Oh, okay, here, no? Okay, I'm sorry. I'm sorry. So that is, this is, this becomes how much here? This becomes, I'm sorry, just make a manipulation. This becomes 30, okay? Okay, thank you. This becomes 30 and this becomes how much here? Yes? 78, am I right? 68 or 78?
78.
Okay, this becomes a 78. So please make the manipulations here. Only I have multiplied this with this, so we have to multiply this also, to multiply this also. So it becomes a, this is a 30 divided by s square, and this is a 78 divided by s. Please, okay, make this manipulation. So now shall we go for the next example? When I will provide the notes, I will make this correction and I will send you, okay. Now find the Laplace transform of t cube plus t square plus t plus 1 into u of t plus 1. See here, instead of t plus 1, they have given t minus 1, they have given it as a t plus 1. We have to be a little bit careful in this case. Okay, so Laplace transform of this. This is what here? This is your f of yes. Can anybody tell me here? T plus 1. If it is in terms of minus, then you have to take this as f of t minus 1. If it is in plus, in terms of plus, you have to take this as in terms of plus. U of t plus 1. So what happens? This is e to the power s plus s into f bar s. So your f bar s means you have to find f of t here, then apply Laplace to that, you will get the required answer. So what happens here? F of s t plus 1 is equal to t cube plus t square plus t plus 1. So I want f of t here, so I have to change t to t minus 1. Okay, so what happens? F of t minus 1 plus 1 equal to, see here wherever t is there, you have to put t minus 1. That becomes t minus 1 whole cube plus t minus 1 whole square plus t minus 1 plus 1 as it is. So here this one get cancelled, so you will get f of t. Here t minus 1 whole cube formula means how we are going to write a cube, that is this one, t cube minus b cube, b is 1 here, that is 1, then 3 times a into b, minus 3 times a into b means minus 3 into t into 1 minus sorry into a minus b. A is 1, a is a t, b is a 1 here, so t minus 1 you will get. Is that clear? This a cube minus b cube formula is clear? A minus b whole cube, I am sorry, not a cube minus b cube. We are going to write a minus b is equal, a minus b whole cube is equal to, this is a cube, yes, minus b cube minus 3 times a into b into bracket, this is what? A minus b. Am I right? Definitely. So expanding this, what you will get? A minus b whole square formula, t square minus 2t plus 1. Then this plus you take inside the bracket, so you will get plus t minus 1. This is plus 1 as it is. So please observe here after this step. Otherwise, we will simplify it one more step here. T cube is only one term there, or we will simplify it. See, t cube I'll keep as it is, then this 1 as it is. 3 into t into, see, 3 into t into 1 is 3t into this t, that is 3t square. Okay, then minus into minus, minus into minus, this is plus, you will get here 3t to 1 is 3t. The next, this t square as it is. Okay, this t square, I think it is plus, isn't it? Oh, you got it. 3 square. Okay, no, let me check. This is plus t square. Then this is minus 2t plus 1 as it is, plus 1 plus t as it is, minus 1 as it is, plus 1 as it is. So we'll simplify this. So this plus 1 minus 1 get cancels. This plus 1, this minus 1 get cancels. So this t cube, you kept this as it is, minus 3t square plus t square, minus 3t square plus t square, you will get here minus 2t square. Then you left with only 2t, that you have written here 2t. This is clear? This is clear? Please tell me. This is clear, no? So next, this is your f of t. This is your f of
3t minus 2t.
But yes. Sign confusion. No, then. Okay. See, some typing mistake happened there in urgency. Okay. This is minus 2t. It becomes. I'm sorry. This becomes minus 2t minus.
No, sir, it is positive T, 2T.
1 minute. Okay.
It's right, sir.
Definitely. 1 minute. We have missed 20 there. Okay. I have not considered. Okay. All are alert, no? Okay. So this is here. This 3t plus this t, that becomes a plus 4t minus 2t, that is plus 2t. Okay. This is right. Okay. Clear? Clear now?
Yes, sir.
Okay. Now we have to apply Laplace to this. If you apply Laplace to this, what happens? Laplace transform of f of t is equal to L of t square minus, t cube minus 2t square plus 2t. Now, since Laplace operator is a linear operator, operate this term by term. What you will get? Laplace transform of t cube is 3 factorial divided by s raised to n plus 1. N is equal to 3 here. So it becomes a 3 factorial divided by s raised to 4 minus this 2 as it is. Laplace transform of t square is what? 2 factorial divided by s raised to 2 plus 1, that is s cube, then plus 2 as it is. Laplace transform of t is 1 factorial divided by s. What is this? Whether I am right here, whether I am right, some typing mistake has happened here. What is the Laplace transform of t? It should be what? Square, isn't it? Right? Right or wrong?
Yes, sir, right.
Okay, here I have missed this term, so that is Laplace transform of t is 1 divided by s square. So further, if you simplify, therefore what you will get? Laplace trans. This is your f bar s. Okay, if you simplify, Laplace transform of t cube plus t square plus t plus 1 into u of t minus t plus 1 is equal to e to the power s into 3 factorial is 6 divided by s raised to 4 minus 2 factorial is 2 only. So 2 into 2 is 4 divided by s cube plus 2 into 1, that is 2 divided by s. This is the final answer. Okay. Hope. I'm sorry, there are some typing mistakes. I'll make that correction. Okay. But I hope these problems are clear now.
Yes,
Clear,
sir.
no? Clear now, all of you? Clear or not?
Yes, sir.
Okay. Let me take one more example here. See, find the Laplace transform. This is one of the important example. Find the Laplace transform of t square minus 6t plus 9 of e to the power minus of t minus 3 minus of t minus 3 into u of t minus 3. Okay. Now we have to find Laplace transform of this. Because of presence of this, you should think that this is not your f of t. This is your f of t minus 3. This is your f of t minus 3. So we'll apply Laplace to this. We'll use the property, second property. Okay. Then Laplace transform of t square minus 60 plus 9 du of into e to the power minus t minus 3 into u of t minus 3 is there. Because of this u of t minus 3, a is equal to 3 is here minus 3. So you can write this one as e to the power minus 3s into f bar s. This is basic step. Now our aim is to find this, and if we find this and if we substitute here, then our problem will be solved. Okay. So to find this, we have to consider this part. What is that? F of t minus 3 is equal to t square minus 60 plus 9 into e to the power minus t minus 3. See, by observing this, I have written it directly. It is of the form a square minus 2ab plus b square type. That is, it becomes t minus 3 whole square. I have written it directly. If you don't know how to write this directly, you can substitute wherever t is there. You can substitute t minus 3 and then you can simplify. Definitely you will get the same answer. If you write like this, your problem will be solved very quickly. Is that clear? So here it is f of t minus 3. So I want to make it f of t. So for that purpose, what we will do, wherever t is there, we will put that t is equal, changing t to t plus 3. So what happens? F of t plus 3 minus 3 is equal to, so here what happens? I will write wherever t is there, I will write t plus 3. T plus 3 minus 3 whole square e to the power here minus of t plus 3 minus 3, t plus 3 minus 3. So what happens? This 3 cancels, this 3 cancels, this 3 cancels. You will get finally f of t is equal to, this is t square. Am I right? This is e to the power minus t. Is that clear? Sure?
Yes, sir.
Okay. Then now this is your f of t. You got now. This is your f of t. Now to this f of t, what we will do? We shall apply Laplace to this. Laplace transform of f of t is equal to Laplace transform of t square into e to the power minus t. So if it is Laplace transform of product of two functions, t square into e to the power minus 3 minus t type, what you are going to do here? You can use either shifting property or effect of multiplication by t raised to n, isn't it? Both the properties you can use, but whichever is easy one, you can go for that. Here a shifting property becomes easy one. What is that shifting property says? What your shifting property says? What your shifting property says? Laplace transform of, yes, can anybody? Do you remember or not? Laplace transform of e to the power at, or you can take minus at into f of t. This is equal to what? Yes, this is equal to what? I have written directly this one as f bar of s plus a. Am I right? Means you have to find Laplace transform of f of t here. After getting Laplace transform of f of t, wherever s is there, you have to replace that by s plus a. If it is plus, wherever s is there, you have to replace that by minus a. So here it is of the form of e to the power at into some standard function f of. I will treat this as your f of t. So I will find a Laplace. I will write this one as Laplace transform of t square, where it is multiplied by e to the power minus t, means s changing to s plus 1 using a shifting property. Is that clear?
Yes, sir.
Now, what is the Laplace transform of t square? 2 factorial divided by s cube, where s changing to s plus 1. Therefore, what happens? Wherever s is there in this result, put s is equal to s plus 1. So, you will get a 2 divided by s plus 1 whole cube. This is your f bar s. So, finally, what you will get? Pick up this f bar s and substitute here. So, you will get finally Laplace transform of t square minus 60 plus 9 e to the power minus t minus 3 into u of t minus 3 is equal to e to the power minus 3s into 2 divided by s plus 1 whole cube. This completes the problem. Is there any difficulty up to this?
No, sir.
Here and there some mistakes are there. Typing mistakes will make that corrections. Okay. Now, see. Now, up to this we have taken only basic examples. Now, in the next class, we will take we'll we'll take some examples on converting discontinuous function into unit step function. Sorry, unit step function or Heaviside function. Then we will discuss how to find the Laplace transform of those. One such type of example will be asked in your examination. Okay, shall we stop here?
Yes, sir.
Okay, just wait 1 minute.